All right, for today we're going to expand on our finding the rate of change for linear, quadratic, and exponential functions, and we're going to use the table of values. So we kind of hinted at that in the last video where I had you put the equation in and then you went and looked at the table of values. So today should be pretty simple, and I think we'll do okay. I reminded you up here at the top, rate of change is the slope of the line that connects 2 points. Remember that linear functions have a constant rate of change, meaning it doesn't matter which 2 points you pick, the slope will be the same. And quadratic and exponentials have a variable rate of change. The points you pick will change the slope, so it depends on which points you pick. So in our first example, I give you just a table of values, and I ask for you to calculate the slope twice. If you get the same slope, that's going to be linear. If they're different, we need to then go back and take a look at our table of values, and that's what we were doing before, and identify whether this is linear, quadratic, or exponential. All right, so I say for x is -2, and when x is 0, so remember those are just the x values. We want to go back and get the y value, so if x is -2, y is also -2. If x is 0, y is 4. Once we have that, we're going to use our slope formula. y2 minus y1 over x2 minus x1. So we ended up, top and bottom both have that negative, so we're going to just change those into positive, because minus a negative. So now we got 4 plus 2, it's going to equal 6. 0 plus 2 equals 2. And that's going to simplify down to be a 3, because 6 divided by 2 is 3. So that means it's a slope of 3. Now let's take a look at our second set. I'm giving you 2 x values there. The first x value is 1, and the second x value is 2. So if x is 1, my y value is 7. If x is 2, my y value is 10. Once I have my 2 points, plug them into the slope formula. We have 10 minus 7 over 2 minus 1. So I get 3 over 1, which is 3. These guys have the same slope. This is going to be a linear. We can go back and look. -2 to 1, we'd have to add 3. 1 to 4 is adding 3. 4 to 7 is adding 3, and 7 to 10 is adding 3. So our first differences are the same. It's a linear function. All right, for our second one, same thing. We're just going to calculate the slopes. If they're the same, we're going to think linear. If it's not, we got to decide whether it's quadratic or exponential. So if x is -2, my y value is -6. And if x is -1, my y value is -6 also. Put them in the formula. I got -6 minus -6 over -1 minus -2. Bunch of negatives in this one, but remember minus a negative turns those guys positive. So -6 plus 6, that equals 0. -1 plus 2 equals 1. 0 divided by 1 is 0. So it's a 0 slope there. Let's take a look at these other 2 x values. So when x is 0, your y is -4. And when x is 2, your y value is 6. Now I have my 2 points. y2 minus y1 divided by x2 minus x1. Minus a negative turns positive, so I got 10, and 2 minus 0 is 2, so we get 5. These guys are not the same, so this is definitely not linear. I'm just going to cross them off. I'm not even going to look at them anymore. I need to decide what it is, though, so let's take a look at the differences. There's no difference between -6 and -6. -6 to -4, I'd have to add 2. -4 to 7, That'll be 0 on yours. Sorry, this will be 0 on yours. -4 to 0 is +4, and 0 to 6 is +6. So I've got, the first differences are not the same. We already said it wasn't linear. 0 to 2 is an add 2, 2 to 4 is an add 2, and 4 to 6 is also an add 2. So this guy is quadratic. And then for our last one, all right, I put the table the other way. It really just doesn't matter. You're still going to do the same thing. I'm giving you two x values. If x is 1, y is 3. If x is 3, y is 27. And then we're going to use our slope formula. 27 minus 3 divided by 3 minus 1. And I'm going to get 24 divided by 2, which is 12. It's a positive 12 slope. All right, let's check out 2 to 4. My x value is 2. My y value is 9. And if my x value is 4, my y value is 81. So I'm going to end up with 81 minus 9 divided by 4 minus 2. So 81 minus 9 is 72. 4 minus 2 is 2. 72 divided by 2 is 36. Those are not the same. So we know it can't be linear because a linear function has a constant rate of change. It'd be the same each time. So we need to look at the differences on our y's. What's happening? Well, here I'd add 6. Here I'd add a whole lot more than 6. And then a whole lot more. And if I notice that what I'm really seeing is times 3 each time. So remember from before spring break, if we multiplied by 3, or if we multiply between our terms, that made it an exponential. All right, so for your classwork, homework, it's the same thing now. Finish the problems that I've given you. There are a total of 6 of them, and put your answers into the Canvas quiz to check how you're doing. Let me know if you have any questions.